We've got a real head-scratcher of a scientific paper, analyzes data from the James Webb Space Telescope. It's about this exoplanet called WASP-15b, and the title, well, buckle up, BOWIE-ALIGN. JWST reveals hints of planetesimal accretion and complex sulfur chemistry in the atmosphere of the misaligned hot Jupiter WASP-15b.
Quite a mouthful. We're talking cutting-edge astronomy here. This WASP-15b is what's called a misaligned hot Jupiter, which is already unusual.
Okay, so break it down for us. What's a hot Jupiter in the first place, and what makes this one misaligned?
So imagine a gas giant like Jupiter, but picture it orbiting extremely close to its star. That's a hot Jupiter in a nutshell. Scorching temperatures and a wild ride. But WASP-15b, it's tilted. Its orbit is way out of whack compared to its star's rotation.
So it's like this planet decided to break the rules of the cosmic dance floor.
Exactly.
What do we know about this rebel's vital stats?
Well, WASP-15b is a real bruiser, about 1.4 times wider than Jupiter.
Okay, so we're talking seriously massive here.
Definitely. But here's the catch. It's only about half of Jupiter's mass, meaning it's puffier, less dense. And get this, its temperature is a mind-blowing 1676 Kelvin.
Wow, that's hotter than molten lava. How do scientists even begin to study something so incredibly far away and hostile?
Light. It's all about analyzing the light that passes through the planet's atmosphere when it crosses in front of its star. They used an instrument on the JWST called NIR-SPEC, which captures the spectrum of light that has passed through WASP-15b's atmosphere. It's like a fingerprint revealing the different gases present. Well, the data showed strong signals of water vapor and carbon dioxide, which isn't entirely surprising for a gas giant. But here's where it gets interesting. The levels of these elements are much higher than expected. This points to what astronomers call a supersolar metallicity. In astronomy, metals are any elements heavier than hydrogen. In helium, supersolar means WASP-15b has way more of these heavy elements than our own sun. It's like finding a gold nugget where you expected plain rock.
That's quite a find. So how does a planet end up so metal-rich?
It suggests WASP-15b didn't just form from the gases surrounding its star. It probably went on a cosmic feeding frenzy, gobbling up rocky planetesimals, basically leftover building blocks from planet formation.
So this planet was a bit of a bully pushing around smaller objects in its path.
And this ties into why its orbit is so wonky. Those collisions, those gravitational interactions, could have easily knocked it off kilter.
It's amazing how scientists can piece together this whole history just from studying light. But speaking of light, the paper also mentions a really puzzling finding, something about a mysterious absorption at a specific wavelength.
The researchers found this absorption feature at around 4.9 microns, which doesn't really match up with any known molecules in that kind of environment.
A cosmic mystery molecule, that's kind of exciting.
The leading theory, and it's still very much a theory, is that this absorption could be caused by a molecule called carbonyl sulfide, or OCS. Finding OCS on WASP-15b would be a huge deal.
Why is that? What's so special about OCS?
OCS is typically found in much cooler environments. Finding it on a scorching hot Jupiter like WASP-15b would challenge our understanding of how sulfur behaves in extreme environments. It would be like finding a polar bear in the Sahara Desert. Totally unexpected.
Other contenders for this mystery molecule, or is OCS the frontrunner?
While OCS is a strong possibility, it's not a done deal. The researchers are careful to point out that the 4.9 micron feature could be something entirely new, a molecule not even in our current databases. Imagine that, discovering a new molecule light years away.
That would be groundbreaking. But even if it is OCS, this research is already changing what we know about WASP-15b. It's more than just a hot Jupiter. It's a misaligned, metal-rich, potentially sulfur-packed puzzle.
And that's what makes this discovery so exciting. WASP-15b is a reminder that we still have so much to learn about the universe and the strange, wonderful worlds it holds.
Speaking of learning, I'm curious about this BOWIE-ALIGN survey mentioned in the paper's title. What's that all about?
It's using the James Webb Space Telescope to systematically study a whole bunch of misaligned hot Jupiters. They're looking for patterns and trends to understand if there's something unique about how these tilted planets form.
So it's like taking a cosmic census, but focusing on the rebels of the planetary world.
Precisely. By studying these outliers, we can gain a deeper understanding of the forces that shape planetary systems, including our own.
It makes you wonder what other secrets are these misaligned planets hiding, and what will we learn about our own cosmic neighborhood by studying them? It's incredible to think that by studying these misaligned hot Jupiters, we might unlock some of the mysteries of our own solar system's formation. But before we get ahead of ourselves, we're still trying to wrap our heads around WASP-15b itself. This whole sulfur chemistry angle is pretty mind-boggling.
It really is a game changer. You know, for a long time we thought of sulfur as this rather inert element, mostly locked away in rocks and ice. But WASP-15b is showing us that sulfur might be a lot more active in the atmospheres of hot Jupiters than we ever imagined.
So it's like suddenly discovering a whole new flavor profile in your favorite dish.
Exactly. And now we need to figure out what recipes the universe is using to create these flavors. That means figuring out the chemical pathways that lead to OCS or other sulfur compounds in such extreme environments.
It's like a cosmic chemistry lab out there. And speaking of labs, we talked earlier about those general circulation models at GCMs. Are those helping us understand this sulfur puzzle?
Their essential GCMs allow us to simulate the complex dance of different molecules in a planet's atmosphere. By adding sulfur to the mix, we can see how it interacts with other gases, how it's transported by winds, and how it might contribute to the overall atmospheric makeup.
So it's like hitting fast forward on atmospheric chemistry and seeing what happens over thousands or even millions of years.
Precisely. These simulations can help us pinpoint the key factors that influence sulfur's behavior in these extreme environments. It's about connecting the dots between temperature, pressure, the presence of other elements, and how they all interact to create the unique chemical cocktail of a hot Jupiter's atmosphere.
It's amazing how much information scientists can glean from just a sliver of light passing through a distant planet's atmosphere. But I imagine there's still a lot we don't know. What are some of the big remaining mysteries when it comes to WASP-15b and its unusual chemistry?
Well, first and foremost, we need to confirm OCS definitively. As exciting as that discovery would be, we need more observations to be absolutely sure. And if it's not OCS, then the hunt is on for other potential candidates, which could be even more groundbreaking.
It's like having a blurry photograph and trying to figure out what's in it. You keep enhancing the image until finally things become clear.
That's a great analogy. And in this case, the enhancement comes from more powerful telescopes, more sophisticated instruments, and more innovative data analysis techniques.
And what about those other misaligned hot Jupiters out there? What can they tell us about WASP-15b and the broader processes of planet formation?
That's where the BOWIE-ALIGN survey comes in. By studying a whole population of these misaligned planets, we can start to see if WASP-15b's strange composition and sulfur chemistry are unique or part of a larger trend.
So it's about looking for patterns and connections, like assembling a giant jigsaw puzzle of planetary formation.
Exactly. Each misaligned hot Jupiter we study adds another piece to the puzzle, bringing us closer to understanding the chaotic dance of gravity collisions and chemical interactions that shape planetary systems.
This has been a wild ride. We've gone from a seemingly ordinary point of light in the night sky to unraveling a tale of cosmic gluttony, orbital chaos, and a whole new understanding of sulfur chemistry.
And that's the beauty of science, isn't it? It's about always pushing the boundaries of knowledge, peeling back the layers of the universe to reveal the wonders that lie beneath.
Well said. WASP-15b might be billions of miles away, but it's a powerful reminder that the universe is full of surprises, and that even the most seemingly alien worlds can teach us something about our own place in the cosmos. Until next time, keep looking up and never stop questioning.